So I'm John Cope. I work for Red Hat in the CTO office. Jeff and I work closely together on this project. We authored the Rook-Ceph bucket provisioner, which is the primary subject of this talk, and the bucket provisioner API, which we'll also address. It's a library that we use to implement the provisioner. It handles all the control loops and everything that should make provisioning development much easier for most object vendors.
And doing the same thing. John and I work together at Red Hat. And so this is what we're going to cover. I'm going to do about the first 3 bullets, and John will do the last 3, including a demo. What I'd like to see a show of hands is how many people here have hands-on experience using Kubernetes? Because I want to know whether I have to explain very much or not. Okay, so a lot of people. And how about hands-on experience using Rook? And again, most people do. So if you didn't have your hand up and you have a question, definitely ask it at the end or grab us afterwards. So that means I'm going to go over the next slide quicker. But I actually grabbed this quote from Kubernetes out of a Red Hat OpenShift description where they're trying to differentiate OpenShift from Kubernetes. But it's a good description, and almost every word there has meaning. It's open source, it's popular, there's a very vibrant community around Kubernetes. There's a dozen or so SIGs, including SIG storage, which we have people in the room that participate in. And the other thing that matters is that Kubernetes has a storage abstraction layer. And that's really the basis of what this presentation is how we key off the well-understood storage abstraction layer of Kubernetes and bring that into Rook-Ceph. And then the Rook stuff, which most people know, and I think, and Alexander just covered this slide. But the important point here is that although Rook-Ceph is a great storage orchestrator, with all kinds of different storage, there isn't a way to provision a Ceph RGW bucket in Rook-Ceph. And so it's one piece that's missing. You can do all kinds of things related to objects. You can provision the object store. You can provision a user in that object store. The author of that's in the room, but you can't provision the bucket yet. Okay. So the motivation for us writing a bucket provisioner and choosing Rook-Ceph was basically, like I said, it's a way to complete the storage picture with a simple, intuitive control plane. You have a consistent way of provisioning file storage, block storage, and with this now object storage. So that's our motivation. And it also was a way for us to test and showcase the bucket provisioning library that we have, which we're going to go into in more detail. So anybody can do it. If you know some things about Kubernetes and you understand the object store that you want to provision buckets in, you can write a bucket provisioner. And everyone could write their own, and they'd all be a little different. And the way they would interact with the pod, which is a working unit in Kubernetes, would be a little different. We wanted to standardize it. We wanted a contract that application developers could count on so that they could move their application if they wanted to from S3 in the cloud to Rook-Ceph on-prem. It would facilitate portability better if we were opinionated about what the names of certain keys should be for endpoints and credentials. And so we have a library that does that for you. And a benefit of this library is that you only have to have your expertise in your particular object store. It's S3 or it's EdgeFS, Minio. Well, I guess they're now called Min.io. Their community voted for a little bit different pronunciation of their name. But you know the object store, but you don't have to know Kubernetes when you use our library. You just import. It's an import statement. A couple of import statements, you have a library, and you focus on the knowledge you have about your object store and let the library take care of the rest. That definition of Kubernetes that I skimmed by, it said it was extensible. This is what we're doing. We're using CRDs, extending Kubernetes so that it can recognize some new resources that we're describing today. This library is not an operator. You might hear a lot about operators, especially if you stay for KubeCon. It is a library in the old-fashioned sense of a library in that you include or import code and it's part of your binary. A goal I've covered some of this already, but the library, it's opinionated, but it's agnostic. It's opinionated on certain names that will help application portability, but it doesn't care what the underlying object store is. So it can be used for any kind of object store. And the last bullet is just a lot of focus in Kubernetes is dynamic provisioning of new storage, greenfield we call it. But we want the experience to be the same for users of the library, whether they're using new buckets or existing buckets. So a little bit more detail on what we do. Kubernetes has the concept of a persistent volume and a persistent volume claim. Have any of you used that in the room? PVs and PVCs? About a third of the hands up. So more than half haven't used them. A PVC, or a persistent volume claim, is a request for storage. And the idea, and it's an abstraction in Kubernetes, the idea is that I don't really necessarily care where the storage comes from, I just need 200 gigabytes or something. And I want it to be block or file. The application probably cares about that. We have the same idea, and then when the request for storage has been satisfied by Kubernetes, you get a PV, a resource that describes what your storage is. And we have the same concept for buckets. You request a bucket with an OBC, or object bucket claim, and when that request is satisfied, the library produces some Kubernetes resources, one of which is an OB, or an object bucket, analogous to the PV. So it's a familiar naming and pattern. Storage classes are the key to dynamic provisioning in Kubernetes for file and block, and they're also the key for provisioning new buckets in the library and for Rook-Ceph. And where we differ a little bit from what traditional Kubernetes PVC model is that you don't mount a bucket, right? You get credentials, and those are in a Kubernetes secret. It's a native resource in Kubernetes, and you get an endpoint information, and those are in a native config map. Again, part of core Kubernetes. So your pod isn't mounting a bucket, it's consuming a configuration map, a config map, which has endpoint data, and it's consuming a secret which has credentials unique for your access to that bucket. Under the covers, when you've written a provisioner, all of the complexity of retry logic, eventual consistency, error recovery, watching for events that happen is all taken care of by the library. So again, as the provisioner author, you're not worrying about that stuff. And this is the connection point between the library and, in this case, the Ceph RGW provisioner. There's 4 functions or methods or APIs that we define. Provision is creating a new bucket. Delete is removing that bucket. The provisioner itself will have to do what it needs to do for its own object store when it creates a bucket. It will have to create the physical bucket and policy users, ACLs, whatever it is, around that bucket. Delete says undo all those things. The library will remove Kubernetes resources. The provisioner removes resources specific to the object store. And at the bottom, we have for existing buckets a way to grant access to a bucket through the library's method and take that access away. And now John will give you the next layer of detail.
All right, thanks, Jeff. So current implementations of provisioners using this bucket library that Jeff was describing, we of course Rook-Ceph RGW, which we'll be demoing at the end of this talk. We have a AWS S3 iteration, which is also a proof of concept to test and show that the library works just as well for that. Nuba is in progress, has one in progress. They're developing it themselves. And then in the future, we'd like to also develop one for Azure and for Google Cloud storage to hit all the major cloud providers. So a little more information about how the provisioner runs. The provisioner is a Kubernetes controller living inside the library. When you define your provisioner, or your provision method rather, the library will call that provision method when it detects a new OBC. When the OBC is created, the library controller detects that, creates a bucket, then like Jeff was saying, creates a secret and config map in the namespace of the claim. Then that is consumable by the application pod. So the structure of the OBC is pretty simple, and we try to follow Kubernetes conventions. You have generate bucket name. Apologies. Generate bucket name behaves like generate name in Kubernetes. You get a randomized suffix at the end of the name. Bucket name allows you to pick a static bucket name. You do run the risk of bucket name collisions in the object store, but you just have to be aware of that. And then, of course, the storage class name. The storage class on the right-hand side here, key things to note, of course, the provisioner. This is a value passed to the library to tell it that it is, in this case, the Ceph provisioner rather than AWS provisioner. And that's how it differentiates between object bucket claims. Parameters are specific to the provisioner. So in the case of Ceph, we have a region, object store name, object store namespace. Now, if you were running an AWS or down the road GCP or Azure, the parameter list would be different. And this is actually a normal pattern that you'll see with the existing file and block external library, external provisioner library. And then the reclaim policy here, I think Jeff had touched on already, with delete and the other option being retain. Delete will delete the bucket entirely, and retain will just remove access to that bucket. And then down here at the bottom, you'll see that you can just get the information about the OBCs and the regular way you get data about other CRDs in Kubernetes. Once you create an OBC, you should see these three objects then. The OB, which is non-namespaced, and then the secret and the config map in the same namespace as the OBC. When you're ready to attach this to a pod, there's a few methods you can do it. If your app is fine with these environment variable names, you can do a straight environment from, define the config map, and that'll inject those keys into your environment as is. Or if your app expects different environmental variable names, you can translate those in the pod spec using the environment and then value from key. And the same goes for the secret. So if you were to, if you had in this case, a stateless app running in AWS using S3, if it was consuming the buckets via OBCs, to transition to Rook-Ceph, you would just define a storage class for Rook-Ceph, redefine the storage class name in that OBC, and create the OBC so that you get a Ceph bucket, and then you would reboot the pod. That would reset the values in the pod for the endpoints and the authentication, and then it would be connecting to that Ceph bucket. To delete buckets, it's the inverse of creating. So you delete the OBC, the controller in the library detects that, deletes the bucket, cleans up the API objects that created the secret and the config map in the object bucket. It also deletes the user. In the case of a delete policy, it calls delete. Like I said, deletes the bucket. In the case of retain, it just revokes the credentials and deletes the user. So the current status of the Rook-Ceph and the library is they're both in an alpha state. AWS S3 is more or less staying where it is for the moment. It was more of a proof of concept. We have a number of PRs and issues, and we're open to any kind of help that anyone wants to provide. Nuba is ongoing, and then again down the road, Azure and Google storage would be the next targets. There's a few restrictions that have come with the library. It's very new, and so it doesn't have things like event recording or the ability to cancel buckets in progress. But those are things we intend to add. One key thing we'd like to expand on is adding a a library-defined parameter key in the storage class for reclaim policy override. That would give us the ability to add an erase function, being that it clears out all the objects but saves the name of the bucket. We know that that's an important thing. You don't want to delete a bucket and have someone else grab that name. And a few other features down the road that we address in issues. You can contribute. We'll have the links here, and we'll distribute the slides. I'll leave that up if anyone would like to take a picture of it. Okay. I'll wait for the cameras to go down. Okay. All right, moving on. And then links, you can find Kubernetes and Rook storage of these links. And we have a set of examples on running pods. We have a simple photo application pod that you can deploy from this examples and blogs repository that will connect to the bucket and allow you to, through a web interface, send and receive photos. Okay, now on for the demo. Fingers crossed. How is the... Can you all read that text in the back there? Is that okay? No? All right, let me...
Define your windows.
Yeah. So, is that a little bit better? Good? Excellent. Okay, so I've divided up my terminal here using tmux. On the top panel, this is a live log from the Rook-Ceph operator. I've got Rook-Ceph deployed already. Let me just... So you can see Rook... Oh, sorry, go ahead. Oh, apologies. Yeah, I'm running in Minikube right now locally on my laptop. I have Rook-Ceph deployed in the Rook-Ceph namespace. On the lower left pane here, I am I have a watch on config maps and secrets. And on the right-hand side, I have a watch on object bucket claims and object buckets. So you'll see those update as we work through the demo. Just to prove that we are running a live demo here. So you can see here we don't have any users in our Rook-Ceph object store, nor do we have any buckets. Now what I'm doing, let me actually. So here I have our object bucket claim. I'm using generate name for the metadata. The storage class, we've got a storage class that exists in the cluster already called Rook-Ceph bucket. And we're going to have it generate the bucket name for us. So what you should see here is in pretty quick succession, the OBC and the OB will pop up on the right-hand side, and the config map and the secret will pop up on the left-hand side. And then I'll list the bucket and the user. Okay. Well, I tempted fate. It appears the object store is crashed. Hold on. All right. Nope, already exists. Yeah. Where's close? Okay, one more time here. And let me just verify that I've got my storage class defined correctly. No. Okay, thanks.
My mic's turned off.
Okay, let me restart the operator real quick.
So
Seems we have a watch issue.
We're restarting the operator, which inside the operator there's several control loops that run today, and we've added the bucket provisioning control loop to that.
Okay. Of course, this worked perfectly 10 minutes before the demo,
Yeah.
or the presentation, rather.
It's running, yeah, there it is.
Okay, so we're streaming logs from the new operator. Should have a pretty clean environment. Let's try this again. Yeah, apologies.
It takes
the
a little
operator
while
takes
for
a
the
little while to boot
operator
up
to fire up.
and start the bucket control loop.
I looked down, I didn't see that happen on the queue control grid. The last message should be object store, my store.
Yeah.
Right? We're just waiting for the log
Okay.
message that shows the object store is created.
All right, demo take 2.
And there it is.
So again, on the right-hand side, you should see the OBC and the OB. On the left, you should see the config map and the secret. Fingers crossed. Oh my God. Okay, there we go.
Yeah.
So, yeah, the gods are smiling upon us. Now to show the values you'll see in the config map. So you'll see here we've got the bucket host and bucket name. The host in this case will be the service for or the URL rather for the store service, and then the name of the bucket, and the port, the region, and in this case we're not using SSL. And then to demo or to show the values in the secret. So here you can see the encoded AWS access key and secret ID that will be injected into the pods when that's mounted. Oh, oops. We have a leftover Ceph user from the initial one, but here we have 2 now. And the bucket you see here in the object store. And that, and so to undo what we've just done, you can do a kubectl. So you see we deleted the OBC, it's cleaned up the bucket, the config map, and the secret. Before it did that, it attempted to delete the bucket in the store. So if it fails deleting the bucket, it's going to leave the API objects there to kind of indicate that something's wrong or that there's been a hang up, and that way we don't end up with an orphan bucket. And just to show that the bucket has been deleted, we no longer have the bucket in the object store. If we had the storage map configured to retain, you'd still see the bucket there, but the user will have been deleted and the credentials would have been invalidated. And that concludes our demo and our presentation. We're happy to answer questions in the remaining time.
How much time do
We have.
If you have questions, I can get you a mic. You're hungry. What? It's okay. There's one.
Hi. So I work with the monitoring pieces on Kubernetes. So since you have created new resources on Kubernetes and you're deploying through Rook, how do I know what a resource is consuming? So just for an example, Kubernetes gives kubelet metrics for PVs and PVCs. Kubernetes gives kubelet metrics for PVCs and PVs. So have you integrated some metrics for your buckets as well there? Or do you have any plans regarding that?
That does not exist yet, but it is something we'd like to add down the road.
Yeah, it's a good question, but the answer is no right now.
Yeah.
But we're
well-
certainly open to anyone that wants to add metrics to it.
Any more questions? And if you could hold the mic a little closer to your face, the speakers are pointed away, so it's actually harder for me to hear it than it is for y'all.
So I think it doesn't matter whether the Ceph cluster is internal or external in your case. I just want to see what is the upper limits if multiple pods are using and how many files each pods can actually, as an application, write to this bucket.
I'm sorry, Jeff, can you hear it better than me?
So
I'm
my
having-
question is, you said AWS S3 is in alpha state and Ceph cluster is in alpha state. So does it matter the Ceph cluster is internal or external to Kubernetes cluster?
No, it doesn't matter.
It doesn't matter. And
Yeah.
how many files can the pods write? I mean, because it's just one bucket that's presented to application pods. Is there like, can I write 1 million files per application pod?
We don't address the file level. We don't go down that deep, so it's strictly buckets. I'm sorry, is that what you're asking?
Yeah.
Okay, yeah, no, we don't set the limits on the buckets. That is something that you can do in Rook-Ceph to set a maximum amount of size or objects. It's something we can add down the road. It would be a Ceph-specific addition, so it wouldn't go into the library just to differentiate that. But yeah, that's definitely something we could do.
Hi. What's your point of view on security? Like, would it be better to have one loop operator per each namespace so it doesn't have access to the whole thing? Does that make sense?
Yeah, no, I understand the question. The perspective on that was to follow a Kubernetes pattern of allowing it to operate on OBCs and OBs and secrets and config maps across all namespaces. We felt that that was a common pattern in Kubernetes. We try to limit exposure to the object store by giving one key per object claim, limiting the rights of that key so that they cannot create or delete buckets. They're only allowed to put and potentially delete objects within the one bucket that they were given for that key. So we're trying to address it at the S3 layer rather than at the Kubernetes layer. Oh, and I'm sorry, and to add to that, the administrators can use cluster role definitions to differentiate which namespaces should even be allowed to create OBs and access secrets in namespaces and things. So we allow, at the Kubernetes layer, there's a bit of security there. All right, any more questions?